So this is just going to cover some very basics of probability. So the probability of an event happening is essentially equal to the number of ways that event can happen divided by the total number of outcomes. So let's just start off with one example. As simple as you can get, what's the probability that I draw a jack of spades from this deck of 52 cards? It's going to be used as a reference point for a lot of the examples I'm going to be doing in this first video on cards. So that's quite literally just 1 divided by 52, and that's equal to 1.9%. So another example, what's the probability that I just draw a jack from the whole deck? There's 4 jacks here. 4 jacks, same thing, 4 over 52 is equal to 7.6%. Now, 2 events. What's the probability that I draw a jack or, and this is what this rounded off U means, or, jack or a king from a deck of 52 cards? Nothing tricky, just think intuitively. There are 4 jacks and 4 kings. So we're left to say the probability of a jack is equal to 4 52, probability of a king, same. So, together, you would just add probability of jack plus probability of king, and then that's 8 over 52, and that's equal to 15.3%. Great. So the question here becomes, is this true for all or questions? Any questions where I'm asking or? Not exactly. It certainly works for this example, but let's look at another. So I'll do a probability that it will rain and a probability that it's hot outside. So this will represent hot, just a Venn diagram here. This will represent rain. Blue is rain, red's hot. Probability that it's hot is, we'll say, 60%. Probability that it's going to rain, that's like 80%. So in this instance, you have what equals to 140%. No, so that can't happen. So what's wrong with the picture? They're not mutually exclusive. And what that means is these events occur together. Whereas in an instance of 2 cards, like our kings and jacks or aces and kings, they are mutually exclusive, meaning it's impossible for any 2 aspects of these events to occur together at the same time and overlap in any form or function. So, in the event that they are mutually exclusive, like these, the aces and kings, the rule is that the probability of A or K is equal to the probability of A plus probability of K in this instance. You add them together. That's only if they're mutually exclusive. That's 8 over 52. We already calculated that. Great. But what about when there's this overlap? And I got more card questions. This obviously changes how we interpret OR, because there exists a shared event. In this question, you have a probability of hearts. If you remember from the diagram, is 13. The probability of a king showing up is equal to 4 over 50. But if you notice, this counts the king twice for both instances because of this overlap, because there's a king of hearts. So we have to account for that overlap. And how we do that is, for this formula, probability of A or B equals probability of A plus probability of B, starts off the same way, minus probability of A and B. And you'll see this notation more. Easy way to remember it is it looks like an A, and the other one looks like a cup. So you could think OR is more, like a cup. OR is more, A is and. All right, good. And B occurring. So you're essentially saying probability of these together, I'm taking my or, I'm getting rid of this and aspect. And what that would come out to is 13 over 52 plus 4 over 52 minus 1 over 52. And that would give us 30.7% chance.